are legendary.
In this scene, Hangman is going to land the F-18 Super Hornet on the aircraft carrier USS Abraham Lincoln. The pilots of these aircraft need to understand the concept of relative velocity and use it to their advantage when landing. The landing speed of the F-18 on an aircraft carrier is about 67 meters per second, and the average operational speed of the aircraft carrier is 15 meters per second. This means due to the relative velocity in the different reference frames, the aircraft witnessed the ship traveling at only around 52 meters per second. While Bill, the fisherman, not traveling at any speed, will witness the aircraft passing him at around 67 meters per second. A non-inertial reference frame is a frame of reference that is accelerating. In this scene, it will be the aircraft, which is undergoing a rapid acceleration in the opposite direction of the velocity it was traveling in. The pilot is the object which is inside the reference frame, which introduces the topic of pseudo-force, because without proper restraints in the aircraft, the pilot would become more like Superman when landing until the pilot hits the water. There is an element of fictitious force or pseudo-force when landing one of these jets due to the rapid acceleration in the opposite direction of the velocity the aircraft is moving in. But first, we need to analyze the collision that takes place to find its actual final velocity. The collision is between the aircraft and the ship. The aircraft is coming in to land on the aircraft carrier, then stays on top of the aircraft carrier as it comes to rest in the reference frame of the ship, meaning this is a perfectly inelastic collision that occurs. The formula that represents perfectly inelastic collisions is potential energy total equals potential energy total prime. The mass and the original velocity of the aircraft and ship are known values. Since two objects move as one, they both have the same velocity after the energy transferred, and the final velocity of the two objects will be 15.00319.868 meters per second in the original direction of travel, meaning the collision is increased the speed by 0.02%. Since we have the final velocity of the aircraft, we can find the change in velocity experiences. I timed how long it took for the landing, and it was about 2.96 seconds. I was able to find the acceleration of the aircraft to be negative 51.99680.132 meters per second squared. I looked up the pilot's weight, Glenn Powell's mass online, and it says about 86 kilograms. With this information, I was able to find how much forward force Glenn Powell feels when the aircraft is experiencing a negative acceleration. Using the formula force of pseudo equals ma, this force is completely absorbed by the seatbelt. The force felt by the pilot is 4,471.72 newtons in the direction the plane was traveling in, which should be quite scary considering the force to break rib bones is only 3,300 newtons. But the force is distributed across the whole body, so this does not happen. Springs. One of the most important features to the aircraft carrier landings are something called arresting wires. It's what the planes hook onto as they are landing. As you can see in this clip, you see their aircraft hooking onto one of the arresting wires and stretching the wire as it goes by, until it comes to a complete stop. The runway on the aircraft carrier is 152 meters long, and there are 4 arresting wires spaced about 15 meters apart. In the clip, it appears he lands on the 3rd one, but for safety reasons, I will use the distance to the end of the runway from the 4th wire, which is 92 meters. I'm able to find the total kinetic energy with the mass and the velocity, which I previously found. Also, the force of friction as the coefficient of friction between asphalt and tires is 0.75. With this, I am able to find the kinetic energy prime, which I'm able to input into the Hooke's law equation to find the K value of the arresting wire to stop the aircraft on the landing strip. So this scene is definitely possible as it is practiced in real life. Now on to the second clip to analyze the centripetal acceleration.
放住我！
Here Tom Cruise is doing a time run in his F-18. He eventually comes to a valley which causes him to form a circular-like pattern and causes him to, in an aviation term, to pull up very quickly. He undergoes a great amount of G-force, which also acts as a pseudo-force. He undergoes up to 9.5 Gs, which is almost impossible, but let's find the velocity that would make this clip possible. The length of an F-18 is 17 meters. In this clip, it shows the aircraft flying, so I can draw this line to make a scale, to find the radius of the turn he does. The radius of the turn is about 233.75 meters. Now since I have the radius and the force, which is 9.5 times the force of gravity, I can make an F-net statement and rearrange and isolate for the velocity. The final velocity says to be around 147.59 meters per second, or 531 kilometers an hour. In a split second of this clip, I was able to find this, which says 519. I'm not sure if this is a velocity reading, as I did extensive research on the cockpit of the F-18, but found nothing. But these two numbers are fairly similar, and this scene will be true if he is traveling at this velocity.